Thank you, everyone. So today I will present you the opportunities and challenges in monitoring forest disturbances through a remote sensing tool. Next slide. So I work for the JRC, which is a European Commission's in-house science service. This means we do research independent of commercial and national interests. And we conduct research to support the policy-making process in Europe, working with several different DGs of the Commission. So we have our headquarters in Brussels, and the JRC researchers are spread across 5 sites in Europe. My own research focuses on using remote sensing to better understand forests in Europe and the changes they are going through. These changes are profound and accelerating. Next slide, please. So, a study by a colleague of mine projected for some of the most important tree species in Europe forest how climate change could affect where they could grow. Here, I show the example for field maple, Norway spruce, and Cecil oak. In blue, you see areas where, by the end of the century, and according to a moderate emissions scenario, the species may find newly suitable habitat. In yellow, you see where the species grow now and will be able to remain. And in red, you see areas where the species grow now, but will not be able to survive by the end of the century. And for Norway spruce in particular, these areas are very large. But the effects of climate change on European forest are not something we will see at the end of the century. We are seeing it already now. Satellite data, here processed by researchers in Austria and Germany, shows that canopy mortality has increased in Europe forest in the past 30 years. When the canopy is less healthy, it affects photosynthesis and ultimately how much CO2 forests absorb. Sorry, next slide. Sorry for, I don't see the slide, so I'm the carbon sink in the EU's forest in slide number, I don't know. So about the graph on the carbon sink. The carbon sink in the EU's forest is decreasing, and the green lines in this graph show how many metric tons of CO2 equivalent European forests are absorbing. The orange lines also consider agriculture, which is a net emitter of carbon. And the lower on the graph the line runs, the more carbon is absorbed. Yes. The green dot at 2030 is how much carbon forests should absorb by 2030 if Europe is to stay on track for its net zero target. And as you can see, between 2010 and 2020, the line is trending upwards towards zero and toward absorbing less carbon. This means the increasing disturbances in forest are making it more difficult for Europe to reach its climate targets. Next slide, number 6. You'll notice that the title of my talk is slightly different from what it is in the agenda. It states forest degradation rather than forest disturbances. The reason I changed it is that the forest degradation can have a very specific definition. For example, in the context of deforestation-free products regulation, other legislation, such as the Habitats Directive, talks about habitat deterioration, or the Nature Restoration Law talks about land degradation. So for my talk today, I will start from the ecological concept of forest disturbances, independent from specific legislation. Forest disturbances are then relatively discrete events that reduce plant biomass and productivity and lead to changes in the structure and dynamics of ecological communities. Forest disturbances can be grouped into zoos. There are biotic on the left, which includes defoliating insects, barbitus, disease. Those are anthropogenic in the center. And those that are abiotic, which includes wildfires and windstorms. Next slide. Remote sensing is a prime tool to detect forest disturbances because satellite gives a consistent and global view of the forest canopy. However, understanding which agent caused a particular disturbance can be very, very difficult. Next slide. When we consider, for example, anthropogenic forest disturbances, next slide, there is strong capacity to detect on map clear cuts. And you'll hear from Global Forest Watch in this session, who distribute a product that maps clear cuts or tree cover loss globally every year.
Kenji, we are at slide 8 and someone is talking in your background.
Sorry, I share the room with another colleague and it's very difficult, sorry. Do you hear me now?
Yeah, it's okay.
Okay, I'm on slide 10, sorry. So normally the slide 10 is with a biotic and abiotic disturbance type.
Yeah.
Okay, sorry. So similarly, for wildfires, there is a strong operational capacity to detect and map them using satellite data. Next slide. So in the figure you see, we have colleagues at the JRC who operate European Forest Fire Information System, EFIS, which maps fire danger, active fires, and burn areas continuously over Europe. It is free and open and based on satellite data as part of the Copernicus program. Next slide. But for all the other types of forest disturbances, highlighted here in red, we have no Europe-wide monitoring system that gives up-to-date information. You see, so next slide. But at a more local or national level, there are now systems that use a satellite to detect forest dieback early from satellite data. So here you have the example of FORDED. This is a Python package developed by a French laboratory for the detection of vegetation anomalies from Sentinel-2 time series. Next slide. Slide 14. So this tailored system, supported by the ministry in charge of the forest in France, has been used since 2018 to monitor particular disturbances types, such as the large bark beetle earthworks on spruce trees in the east part of France. Next slide.
I need to go
to manage forest disturbances, time is of the essence. Therefore, there is a big demand for near real-time forest monitoring. Satellite constellations provide data that is well suited for this, and there are several algorithms in the literature that are designed to find disturbances in time series of satellite data. These algorithms are not always easy to implement and compare through. So to address this, in our team, we have developed a software package called NRT that provides a standardized interface to multiple monitoring algorithms that is optimized for fast processing. Detecting a forest disturbance in time is important, but then the question comes, what caused it? Wildfires and clear cuts are relatively easy to distinguish in satellite imagery. Rainfall, pest outbreaks are much harder to recognize. So there is some exciting work in this topic in the European Research Project. Next slide. Slide 16. So for example, the Forest Pass project which put out a first prototype. Next slide. Here, zoom in Hungary, colored by the year of the disturbance. Next slide. And here with the town corresponding to the suspected disturbance agent. These products are derived from satellite images with a 30 meter spatial resolution. And at this resolution, you cannot distinguish individual trees. That also means that some disturbances, such as thinning or selective logging, go largely undetected when using these images. But there are satellite data sets of higher spatial resolution. Next slide.
We want to go to the left.
So slide 19. This example is taken from a study of the Amazon. The bottom two images, C and B, show the difference between 30 meters pixels and the 10 meter pixel size the Sentinel-2 satellites of the European Copernicus program provide. At the top, you see an aerial photograph, which much finer resolution. Aerial photographs are available for all Europe, but traditionally they were mostly analyzed through visual interpretation rather than automated analysis. Now, computer techniques are changing that, however, with very interesting results. Next slide. For example, a research group in Copenhagen, for example, trained a deep learning algorithm to map individual canopy dominant trees across all the Denmark. And this level of detail is in forest mapping is unprecedented and opens new perspective also for disturbance monitoring. Next slide. 21. Here you see, for example, very high resolution maps of deadwood cover in a forest in Austria using satellite imagery, Sentinel-2, and using an algorithm trained with drone images. Mapping deadwood with this level of detail is not only useful for understanding disturbances, but also other ecological processes to which deadwood is key. Next slide. Disturbance pathways in forests are complex. Not only are there different disturbance agents, there are also wide ranges of disturbance intensity. And then there are salvage logging, sanitary logging, where humans remove disturbed trees. And of course, there are processes of recovery and regeneration. Right now, we are not able to map all these pathways from remote sensing. And in our own group, JRC, we try to map much more simplified disturbances pathway. Next slide. So we are following this figure where we distinguish between full tree cover loss, the dark red arrow, such as you expect after a severe fire or a clear cut, light disturbances where canopy cover is lost, but trees are left standing, and the transition between disturbed and treeless landscape, such as when salvage logging happens. Next slide. Here is an example from Western Germany on a spruce forest hit by a bark beetle outbreak, on how the different types of disturbances can be distinguished. Sorry, maybe next slide to see the changes. Next slide. So you see we have a logging. Next slide, we have bark beetles, attack. And then we have a classification here. So as more of these algorithms and derived products get published, it is important that we can assess the quality. At the JRC, we have organized a dedicated workshop on this group. Assessing the accuracy of this group products is namely not trivial, and we cannot simply rely on the reported model performance metrics as this is fundamentally different from the map accuracy. This is something to keep in mind whenever interpreting forest disturbance map. And finally, a big obstacle to further improving this kind of products is the availability of high quality reference data on forest disturbances in Europe. Sorry. Next slide. Slide 25. So at the JRC, we have been trying to do something about that by setting up initiative where scientists and others can make publicly available this reference data on forest disturbances in a common public database. We have such a database for forest insect and disease disturbances called DEFID2R. Next slide. And another one for windstorm data called ForWind. If you have the will to contribute, to share your data, do get in touch. To conclude, there are already operational systems based on remote sensing to monitor forest fires on clear-cut, stone replacing disturbances at a global scale. The regional monitoring of specific disturbance types is evolving quickly. But one of the most important bottlenecks for scaling is the lack of high-quality reference data. And finally, disturbances products need to be validated to ensure their use in an operational context. Thank you.
Thank you, Kenji. I think there is room for questions. Are there any questions?
Yeah, there is an applause to you, Kenji, if you will. And questions, I hope you are able to answer one or two, if there is one or two questions. I'm just looking at the audience. Anyone? Then maybe I can ask a question. How these work that you do, you think will influence what's included in the forest monitoring law? Because the previous session was dealing with forest monitoring law, and there are, in some cases, we heard that there is a quite significant pressure from the industry to simplify the forest monitoring law, some of the annexes. So will the Commission consider, you think, your project results?
Sorry, I don't really understand the question.
So the question is your data or your information, how do you think is going to influence the forest monitoring law? Do you think the Commission will consider these? Because it sounds like you are, or the remote sensing and the earth observation is improving really fast. It can have quite a lot to improve the forest monitoring. Will the Commission consider this, you think, in the forest monitoring law?
Okay. I think we will rely on the forest monitoring law because one of the objectives of this law is to improve the sharing of field data about forest. And that's one of the bottlenecks I presented during this presentation. So at the end, if we succeed to have such kind of national data like NFI, we can improve our models and finally improve the monitoring of forest at the European scale. That's my point of view.
Kenji, I have a question too.
Sorry, maybe you have to come here, Carl, to speak to this.
Hi, Kenji. I have a question too. We started out this conference talking about the old growth forests, and the problem there is, that very little is left. A lot of that is sort of in Romania, in the northern part of Scandinavia. Some of it hasn't really been identified, but the areas that have been identified, can you monitor the implementation of protection status of old growth forests?
So sorry, just the last term about monitor what?
Well,
to be sure.
can you actually monitor, if there is going to be illegal logging in like Natura 2000 areas or in protected old growth forest areas?
In fact, yes, we can monitor.
You can do that, right?
It's possible because, as you know, we have the Copernicus program. We have a constellation of satellites with a revisit period of 5 days. So
okay,
you can monitor and see what happened in all European forests.
This means you could do it, but are you doing it?
For it's are we sorry no, systematically no.
Okay.
Well, it's one of how can I say? We are thinking about a monitoring system at the European scale.
Yeah.
Maybe developed with some algorithms made by the GRC or some other European laboratories, but no, it's not operational.
Okay. Thank you. There's another question from Toby Aykroyd. Toby, come on.
Hello. Thank you very much. A great presentation. Could I just follow on from what Carl was asking you? Sorry, I sabotaged it. What Carl was asking you, we know that remote sensing is getting better and better in terms of monitoring, protection and disturbance. What do you foresee as the role for ground truthing, for actually having people on the ground, on site, with valuable in-time information to share?
So what I think about what citizen data? You talking about that? Or?
Yes. I mean, one suggestion has been the formation of a network. Given that so much will depend on member states for monitoring, to actually have an independent network, mainly driven by the NGOs, that supplies on-site information on what's actually happening, particularly across all the old growth forest sites.
Yeah, but you want my opinion about NGO
how
data?
Necessary that will be
to
complement the remote sensing that you intend to use.
Yeah. It's sure it's a complement very important for remote sensing because we need to start an infringement. For instance, we need field data, photograph on the field. Remote sensing is just a part of the analysis here. So I totally agree with you. It's always the same. We need field data also for training, validating remote sensing methods.
Thank you. That's very valuable to have.
But my question is there I don't know, sharing platform for NGOs to input this kind of data with free access, for instance, could be interested for us. Second question is how to evaluate the quality, how to be sure that those data are really good. So that's another issue here.
Yes, there was a proposal from one of the conferences to actually set up a specific dedicated network, and particularly one that involves an early warning system, which is based on intelligence rather than even any evidence. Don't wait till there's a forest track, and much less actually any felling started. Evidence in the local wine bar or rumours, as it were, of impending logging, so that there is actually time to take action. That's one of the main objectives behind the network. And then obviously there are all the other functions it could fulfill as well.
Okay.
Thanks, Kenji. No more questions, so we can say goodbye to you, and thanks for coming and joining us. Then we go ahead for the next presentation. Yeah.
Sorry for the inconvenience with my
okay.
laptop. Sorry.
Thanks.
Have a nice day. Bye.
Bye.